3 p.m. in the Netherlands, here in Noordwijk. It's sunny, it's spring, it's May. We are all excited to talk about a topic that is booming in the optics community, that is booming in epics. We are excited to talk about molded optics. On Monday, May 3rd at 3 p.m., we are going to address the most traditional and right now the fastest growing market for optics, molded optics. This is where demands for high performance meet the need for cost effectiveness. No wonder it is a major driver in automotive lighting. Have you seen the new award-winning headlamps by Vallejo or Marelli? However, during our previous meeting on automotive lighting, Volvo shared their unmet needs in terms of power, field of view, and their vision on having both a low and high beam, maximizing the illumination of the road. And this adds to the upcoming demand for better interior lighting in automotive. So we are bringing back Volvo and its supply chain to discuss how molded optics need to adapt to their new challenges. We certainly can't have a successful meeting on molded optics without Leica in the room. They've spent 107 years developing camera solutions that capture the memories of 5 generations. I want to engage with them about the need for high-resolution features in the optics, which implies high-resolution features in the mold itself. What new materials are needed and what new manufacturing techniques for the molds, such as direct laser writing, nanometer scale 3D printing, or the development of flexible molds. Let's wait for their answer to our famous epic question. The 2-hour discussion will also examine room for cooperation with the manufacturers of the PlayStation 5, Sony DADC. The entertainment world is in a constant flux. The need for novel optics in augmented reality, as well as high-quality streaming to the gamers themselves, has opened up new challenges for the optics manufacturers. These are just 3 examples. If you want to propose your company's molding solution, sign up right now. See you on May 3rd at 3 p.m. The 3 at 3. When is the PS5 going to be back in stock? We definitely need the PS5 back in stock. And we also would like to say that today we have one of the future gazelles in this industry, Cura Technologies, accepted to come here to discuss their challenges in supply chain. We are talking about the 120 field of view. We are talking about 4K projection in the AR goggles. This is something fantastic. Thank you everyone for registering. I see many people in the Zoom room, also many people on our YouTube channel. It is great. We keep getting the support of all the industry. We are now 700 and don't know how many, but we know every one of you individually, and that is never gonna change. This is just a number. We're still a small association because every company for us is a universe. We just need to know what everyone does. And here, my name is Jose Pozo, and I'm talking on behalf of a fantastic group of people, and together with them we organize events, we provide access to a network, we help you raise capital. We have the biggest website to find a job in Photonics, jobsinphotonics.com, check it out. And every Epic member, you know this very well, every Epic member has access to a long list of market reports, which we give all of them to you without extra payment, just for the membership fee. Today, we are in the middle of the season 4. I think, Sana, you know this, we are already more than 100 online meetings since the pandemic started. More than 100 online meetings. Today, season 4, season 4, molded optics. For those of you active in the medical domain, check the one next week on urology. We are extremely excited about it. But every topic here is addressed. There is something for every Epic member. Please register for these meetings as soon as humanly possible. But today, molded optics. And first of all, thank you, our media partner, PhotonicViews. We couldn't make this without you. Thank you very much. But this meeting wouldn't be possible without the support of our sponsors today, all the way from Berlin, Micro-Resist Technology. They are the providers, photoresist and photopolymers for the manufacturing of high-end molded optics. Thank you for being with us today. But all the way from Finland, we have Oplatek. Oplatek is our company manufacturing cost-effective non-isothermal molding method-based prisms, lenses, light guides, non-imaging and for imaging applications. Thank you very much for being with us. ORAFOL, all the way from Jena, they manufacture Fraehnle optics. They started on the solar, but now they cover all the applications, especially the machine vision industry. All the way from Aachen, we have Innolite. Innolite is a company who can provide turning systems, but also the molds for the molded optics. Thank you for being with us. And finally, we finish in Austria, EVG. Florian Aning is represented today. For EVG, they manufacture the semiconductor equipment that go from nanoimprint lithography all the way from Stephan repeat lithography system. Thank you, EVG, for being with us. And thank you to the person who made this meeting possible, the one who worked the hardest in this room to make everyone here happy today, Dr. Amairi-Pyka, or expert in optics manufacturing. Sana, what's going to happen in the next 2 hours?
Thank you so much, Jose. Great introduction. I love the energy in the room. Everybody's here ready to speak. And we have, of course, a nice list of speakers. We'll hear from Volvo. We will hear Volvo cars from Leica camera, from Cura technology, as you said, and from Hofer IPT macro resources. But also, I would like to show you the list of the people who signed up for this meeting. We see a very nice representation of the supply chain, from the end users to the system integrators, the optical designer, photonic component, polymer material, the people responsible for optics and micro optics, like also the representation from the pilot line Fabulous for freeform micro optics. There is people presenting novel material, glass material, of course, other tooling and master generation technologies, and very important are the equipment. From roll to plate, laser scribing, coating deposition. We have a very nice list of guests today, and I can't wait for this meeting to start. If you're missing your logo here, there is only one reason.
Yeah, there's only one reason, because this slide only represents the companies who registered for the meeting today. So you remember you're not there. It's because you forgot to register. Please don't let it happen again. And this meeting is also live streaming YouTube. So hello, YouTubers. If you have any question, please write it in the chat. I will read it in the room. If you want to get in touch with any of the participants today, that's important business here. If you want to get in touch with any of the participants today, write me an email, jose.pozo@epic-aso.com, and I will make sure I make the introduction if you have a nice business proposition for them. Also, I would like to remind everyone that this is also valid in the Zoom room. We had the internal chat here. Use it. Use it. Get in touch with each other. Chat. I don't mind if you are typing during the meeting, because that means you are doing business. But if you want to get in touch with any of the participants after the meeting, all you have to do is drop me an email. Drop me an email and I will make sure I make the introduction. Let's get the meeting started. And as I said in my introduction video, we cannot have this meeting without Volvo being back in the room. After the low and high beam challenge at the previous meeting, we want to find out what are the main challenges in molded optics and what business connections we can have. And today we have with us Paul-Henri Matha, technical leader for exterior lighting of Volvo. The floor and the attention of everyone goes to the Volvo from Sweden, the safest car in the world. The floor is yours.
Yes, thank you very much for the introduction. Yeah. So I hope you see my screen.
Very clear.
Yeah, so I have done small slides, so just to introduce the topic for automotive lighting inside, and just to see and to show you the stakes. Yeah. So I think it is a slide I already presented in one EPIC meeting, but it is a usage of optical parts in exterior lighting. So we have in headlamp from the front, we have in rear lamp from the rear, and we have also interior lighting. So a lot of components with a lot of optical system and different technologies. So what are the stakes for us? So it is for signaling function. So you see, for example, on this picture, the DRL function, so the daytime running light, what we call in Volvo the Torsammer, which is the Volvo signatures. And also we use it for lighting function. So for lighting function, I have seen your video from Polestar. So it is for example, the Polestar 2, where you see the headlamp. And when you see what we have inside, indeed, we have the LED with the PCBs, but we have also optical system with the silicon part component. We have also the lens, which is in plastic, and we have a lot of other components. All these things are part of the optical system. Also, when we develop some optical component, especially for signaling function, so we have some technology like reflector, light guide. inner lens, Faehnle concept, and so on. And each time we combine a different optical system between the LED, which is the input, and the output with light guide combined with reflector and so on. All the signaling functions are done like this for automotive lighting signaling function. What is the main stake for car makers today? So, you know, with electrification, it is especially the power consumption. So you can see on this slide, on the left, you have what we have when we are in daytime running light, when we have some bulb. It was around 50 watts per car. If you design an optical system very efficient, with optical efficiency around 50%, so you will have between 10 and 20 watts. So this is very efficient. We have no topic for this. But when you want to design something very nice, like the Volvo simulators, then the power consumption can be between 30, 60 watts per car, and the optical efficiency will be very, very low. And sometimes we will have a power consumption which is more powerful than a bulb function. We have exactly the same topic with low beam power consumption. So when we are by night, so when we have some bulb in the past, it was around 140 watts per car. With an efficient LED system, which is quite big, what we see, for example, of this Renault Capture, the power efficiency is also quite good, and the power consumption is quite low, around 20, 40 watts per car. But when you want to go to a very efficient system with a very thin headlamp, what you can see on the Volvo S90, for example, then the power efficiency is less good, and the power efficiency at the end can be at the same level of a halogen bulb. And this is today what is very, very important for car makers. So just if you want to have some figures, when we speak about power consumption, so when we have 50 watt power consumption, it is equivalent to 1 gram CO2 when we speak about internal combustion engine. So what we have in the past with gasoline and diesel engine. This is the value during WLTP homologation in Europe. And when we speak about electrical cars, so what we call a battery electrical car, so BEV, it is around 1% of the range. So it will depend on the size of the battery, but 1% of the range is a good value for 50 watts. And then to be able to work on that, we have to work with you about the lumen output per watt, so the lumen per watt of the candela output per watt. And what we have seen just previously is that for lighting function, we are between 20 and 50%, and for signaling, we have around 10%. So this is not good, or it could be improved. And what we need is, if we want to reduce the power consumption, then to be able to reduce the size of the battery or to increase the range of the battery of the car, then we have to develop more efficient solution. So less watt for the same amount of lumen. And the idea is to be able to multiply by 2 the efficiency of the system. And then I put on the right what are the actions and what we are waiting for EPIC member. It is to be able to work on the light source, to work on the optical system, to work on the plastic raw material, on the injection tool, on the tool design, on the optical concept by itself, or all the other things we can develop. So this was my last slide. It was just to do an introduction to show you what we need if we want to improve optical efficiency for automotive lighting. Thank you.
Thank you so much, Paul-Henri, for this very nice talk. And you clearly know the spirit of EPIC. You prepared what you need from the community. But as we have today the meeting on molded optics, I would like to, while waiting for our guest today to raise hand and ask a question, let me maybe ask you about some specifications maybe on the plastic raw material or injection process. Is there any specific need there or something you can share with us in more details? For example, for the material, you can specify on the temperature tolerance, for example, or so on?
Yes, perhaps not for what is important for the material is the transmission. Especially when we have a material with a thickness of 1 millimeter, transmission is not very important. But when you put the light and the length of the part is 50 centimeters, then the transmission, the light transmission is very, very important. So for example, today PMMA is better than polycarbonate, than PC, but perhaps we can improve the PC to have the same properties than PMMA. PMMA, we have some problem with temperature, especially because we use LED at 150 degrees, for example. And then it can be difficult to use PMMA because PMMA limitation is around 110 degrees. So that's why we need to improve the raw material, for example, to increase the transparency and the efficiency.
And when it comes to optical design, what do you mean with
optical design, I've just mentioned just some design. Just here, for example, with a reflector solution, with inner lens, with light guide, it is not very efficient. So perhaps we have to create new design. We have seen some MLA, so micro lens array concept. We have a diffractive optic. We have new design, but for the moment, it is only research. We have not seen in pre-development, and we have not seen in development. So I think it is something which is to be very good, but we have to move forward, and we have to be able to do the industrialization and the development of this technology.
Thank you so much. Let me see if we have any comment from the room. Please unmute. And
there are many comments in the room, which I'm going to voice them out because they are telling me in private. The first comment that I get here is that everybody sees that there is a huge push for plastic. Is there anything going on glass-based optics for, I know, very heavily on interior, but for exterior lighting, is there any activity on that? Is there any challenge that we cover with glass?
Yes, the glass is good, but after with the glass, we have the problem with the weight. So, but yes, glass is good, no issue for that. So we work, for example, in the past with Holofan in France, so it is a good supplier. We have Dr. Optics, so we have a lot of suppliers with glass. So it's not a problem. If we have some good properties with glass, we can use it. I understood that we have limitation with the shape. So especially for the designers, glass is always a question, and always it could be a problem.
You know what is the problem here? Where I see from all these meetings, I realize that end users come here and they have a challenge, and the challenge is always cost is a challenge, weight is a challenge, the materials are a challenge. How do I make these optics come true? And then we have the suppliers who tell you, my optics are the best, my material is the best, my molds are the best, my nano imprint lithography is the best. Sana and me, we've been thinking about how to solve this issue. And 2 weeks ago, I came up I met Oliver from PanDao. And he told me, I think I have a solution for this. PanDao is a new EPIC member. Welcome, Oliver, to EPIC. And most important, PanDao is the company that, in my opinion, can solve this challenge to answer what the end user is asking, to what price, what volume, what lead time, and even what machines can generate it. Oliver, please unmute yourself, because I want you to meet Paul-Henri, but also for the rest, to meet also the rest of the people in the room. You are muted. I have a Mac to celebrate such event.
All right.
Yes.
Now I'm not muted. I'm here. I'm the last minute jumped in. Thank you very much. I'm from PanDao. What the heck is PanDao in Switzerland? Sounds like Chinese and does weird things. I want to show you in just a second. I share my screen, which is very, very dangerous. I do. Look, this is PanDao. We have a software tool. What is the software tool doing? So it just ask glass or plastics. So the question is, what type of a material you use, or what type of technology you use? Optics designers design systems, and then they have to be built. And how do you know? And we have ZMAX and Oslo and Code 5 to support them with software to find the best optical system design. But there's no software for the best optical fabrication chain design. And this is PanDao doing. I will show you. We point you read in lens design, general informations like lens diameter, center thickness, and how much do you want to produce. Also the material, we can handle plastics to glass, to cylinders, to crystals, to calcium fluoride, tungsten carbide. And then what we do is we read in isonorm, center thick, shape accuracy, type A sphere, no A sphere, and so on and so on. And then with one click, ask Mr. PanDao, get, for this case, it's a 4 million pieces you want to produce. It's a PMMA material, and it's a quite small, weird A sphere in plastic. So you can do that. The fabrication chain in this case is injection molding. Wonder why? If you now the optics designer can play around with tolerances and see live what will happen, or maybe more straightforward. If I have only 2 minutes to do, we reduce the number of pieces, and there's popping up turning. If you don't know what this is, you can move your mouse and you get some nice references on that. Now we just be very weird, change the design to glass. If we do glass with this, and we see and we enable emerging technologies, the new stuff around you are all interested in, then we see, hey, it's a standard, traditional fabrication chain jumping in with fluid jet. In the end, if you don't know what it is, read it up here. If we go to numbers again in glass, then you see, and then I'm already done. Maybe some zeros too much. It doesn't matter. It's a live event. So here, and we are down to precision glass molding, which is the counterpart to injection molding for the glass. If you are now very weird, you want to have your lighting not in glass and not in plastics, but I do want a germanium lens. Stupid, I'm not a designer. Last click for the day, then you see diamond turning comes in, because you can't mold germanium as far as I know. Thank you very much for your attention and the opportunity to present.
You know, I am very impressed with this, because you calculate lead time and you calculate price. How do you come up with these numbers? Are my friends for SUS Micro Optics are going to be very upset when you are telling their customers exactly how much they have to charge?
Well, what we are doing is we point to the process. You still need a guy like Wilfried who optimizes the machine to serve the optimum of the process. Not always you need the state-of-the-art process for a certain applicability application. Then it's enough to have 60% of the quality to run. So you need guys like engineers to set up the injection molding machine. We don't set up your injection molding machine, but we tell you, if you choose injection molding, that's what's possible, and it will cost that. If you end up with double fabrication costs, there's somebody doing something wrong.
Okay, we have Wilfred in the room, and you have been just directed mentioned. So what is your take on this? How do you feel that this software exists?
This is great. So, no, this is great. So, I mean, I know Oliver Faehnle, of course, whereas the Swiss community is very small. No, this is great to have such a website where you can see immediately what are your options. What we do at ZÜS is not molded lenses. We make injection or imprint. So it's a little bit different technology, and it's very excuse me, it's very complementary to molded optics. So it's imprint, so where you use wafer level optics basically. So you have, but for we have a very similar supply chain like the molded lenses. So for the masters and the optical design, and so the supply chain and the design is very similar, but the product in the end will be very different. So the more we push micro optics, the better for everyone in the community. So I'm not upset at all. It's the opposite.
Oliver is completely agnostic of the manufacturing process made. So actually, he's also implementing even to photon polymerization here. We discussed this. This is just the beginning of something that is huge, and I fully agree with Wilfred here, Oliver. The industry needs this. I have a lot of questions and comments in the room. I'm going to go to them, but first I want to go back to Paul-Henri Matha. The reason why I want to go back to you, Paul, is because I'm a huge fan of Fraehnle optics. And I was very excited to hear that you mentioned Fraehnle optics in your presentation. Could you share with us some light on this? What are the key applications and what kind of challenges maybe you want to solve with Fraehnle optics?
Yeah, Fraehnle optics, it is very efficient. So this is good. So in the past, we use it a lot for high-mounted stop lamp, especially because we need a lot of flux in the axis. Also for rear fog lamp, for example. But after homogeneity with Fraehnle optics is not very good. So when you want to design a signaling function, because we want to have some very nice signatures, so you cannot really use Fraehnle optics because homogeneity will not be good, because you want to spread the light. You do not want to focus the light. So then we use now the Fraehnle optics to collimate the light, for example, for the low beam and for an high beam. And then after you have another optical module to spread the light. But then we use it just to collimate the light at the light source.
Fantastic, Paul-Henri. I don't know if you know Jürgen Zosel, the CEO of ORAFOL, the way from Jena, market leader in Fraehnle optics. Jürgen, tell us what's on your mind. Maybe you have a question for Paul-Henri. Oh, we can't hear you. This is the problem of doing the show live. Can we see? We can maybe hear you. Maybe let's try again. Unplug the headset. Just unplug it. Pull the cable. We can't hear you because you are not muted. I think it's more difficult problems. Before we go to Jürgen Zosel, my team is going to give you some instructions.
You hear me now?
Yes, we can hear you. Yes.
Yeah, okay. Every time, if I'm not in Teams, I have to change. So, yeah, we are working with the Fraehnle optics also for automotive. And in the last 2 to 3 years, we also did work for lightings and did start to bring in the first Fraehnle lenses for this kind of lightings. And in the last year, we had also a lot of communication, for example, with our material supplier company, Röhm. And from them, they did hear that they developed a new plexiglass based to the 8N material, which is now the Optical HT. Sure, if you know this material, and it's completely developed, for example, for automotive areas, which allows a temperature of 105 degrees. So, and this material is meanwhile also very interesting to use it, for example, for Fraehnle lens for this kind of applications. And I think at this point, we should start a short internal discussion to find out how we are able to support you. So,
this is how things start. After this meeting, I want the two of you to speak, and I will make it possible. But Paul-Henri, before we go to the next speaker, stay with us because there is something very big in Europe right now. Already, SUS Micro-Optics told us, Wilfred, that micro-optics is growing like crazy. And the biggest activity, the legal entity Fabulous, the company Fabulous has a CEO here in the room, and it's Rolando Ferrini. Rolando, what's on your mind?
Thank you, Jose. I was also messaging Oliver because I like very much what PanDao is offering because it's very close to what we want to realize on the pilot line with our marketplace. So to build the entire production value chain and to help people to find the right producers when they need a micro-optical components, in this case, a free-form micro-optical components. So I will try to explore which kind of synergy there can be between the pilot line and PanDao. Also because we are also all in Switzerland, so it's easy also to discuss.
Fantastic. I'm also very excited about PanDao. Actually, I'm asking everyone in the chat to tell me privately or publicly, as they prefer, what they think about PanDao, because I really think this is a huge opportunity for this industry. Paul-Henri, stay with us. We are going to come back to you. But before we do that, I want to move to the next speaker to have a bigger picture already painted in this fantastic meeting. So we're going to go now all the way to one beautiful city. We go to Aachen in Germany. We have Fraunhofer IPT represented in the room by the head of optics manufacturing, the head of the Department of Optics, Tim Grunwald. Tim, thank you very much for being with us from Fraunhofer IPT. The floor on the attention of everyone goes to you. The floor is yours.
So thank you very much, Jose. I was pretty glad that I wasn't the first speaker because I still had to recover from your vivid introduction. And it also gave me the opportunity to put one very important badge still on the slides. I hope you can see them. This member of EPIC. It didn't appear in the first version, but now it is on. All right. Today I'm going to talk about a little bit looking beyond the borders of precision glass molding. So this is what we are here in Aachen dealing with. And also Oliver from PanDao also mentioned it, that it is the best process that you can have. I think that was the message that he wanted to deliver. So I think all of you might know Fraunhofer. We are 30,000 researchers dealing with lots of topics in terms of engineering and life science and so on. And another small margin is dealing with optics. And we in Aachen, we deal with glass molding. And just for recapitulation, I just want to show you how glass molding works. That means we have got some dedicated glass preforms. We put them into very precisely manufactured molds. We heat everything up together. And then we have got these pistons that move to each other, and they will cause the deformation of the glass preforms and will lead them into their final shape. So what we usually do every day in our department is that we start from an optical design. And based on that, we make a first simulation in order how it will look like and how the cost will be in the end, if it is feasible and so on. And the main point that the simulation can tell us is how should the tools look like. And the tools, they will later on be manufactured in-house by means of ultra-precision grinding, for example. Subsequently, they will be coated, and afterwards the molding will take place. And one aspect that is covering the whole process chain is actually metrology. And in the end, we can say that we have got a ready to coat optic or a ready-to-use optic. So, and this is, as I said, what we do every day. But of course, we are also facing some challenges that are mostly coming from industry. And the first thing is that we want to increase inefficiency. It is very obvious that glass will be always more expensive than polymer, but we try to do something that even glass gets more and more cheaper. So that means we can do more glass optics in one shot, for example, 2, or we do even more like multi-cavity molding. And here you can see, I think these are 9 cavities. And we can also step to wafer level glass molding, where we just put a glass wafer into the molds, and then we can manufacture hundreds of lenses in one shot. But this is actually not what I'm going to talk about today. I want to talk about another challenge, which is called the increase in precision. So for just some impressions for you here, you can see some spheres or some free forms or some micro optics. And we are already within fractions of a micrometer if you take a closer look at the peak to valley error. And also the roughnesses are in the single-digit nanometer range. But we think that glass molding has got the potential to do even more in terms of precision, more than, for example, grinding and polishing. But before I come to that, I will just tell you what the problem actually is. So if we just have a bigger picture in terms of optics production, we always have to take into consideration optical design, then the fabrication, the glass molding, for example, the coating and the assembly. So and how does it normally work? We start from an idea. We come to a specification sheet where everything is wrote down what we want to have. We go to optical design, and the optical design tells exactly how much micrometer or nanometer we have in terms of tolerances in glass molding and assembly, for example. So that goes into the manufacturing part. And we start that with the manufacturing report. We do the assembly, have got inspection and so on. And then we have got our usage phase and can trace everything backwards. But as you might see, the information volume is always decreasing and condensed to a very, very small set of parameters. They actually have nothing to do with the actual function of the lens. So today I'm just going to explain you in 2 minutes what we think could be the solution. And later on, this will be the discussion whether you think this is also feasible or actually worth being developed. So actually, glass molding is good for this approach because we can assess many things. For example, the dimensional deviations, but also structural deviations. We can calculate them in our simulation before. And then if we go one step further for the coating, we have got coating warp pitch and so on. And everything of them we can put into our simulation and know how they will behave, for example. And if we know how they will behave, we can directly trace them back to the ray tracing software that we usually use in optical design. And another thing, for example, the alignment errors from the assembly, they will also be trackable in the ray tracing software. So that means we have got everything in one digital environment, and this is what we would call the digital twin of the manufacturing system. So that means if we have got everything in a digital environment, we know already how the subsequent process steps will behave, and we can anticipate them. And the main benefit from that is that we don't need tolerances like nanometers or whatever anymore. So what our goal will be is that this manufacturing system will directly give us the tool geometry, the process parameters for molding and coating, and not a angular tolerance for the assembly, but a light distribution directly. And what we want to do with that is we do not want to have a overall tolerance, and all the differences have to, all the different processes have to fit into this general tolerance. We want to flip those tolerances and capabilities of the processes to the side, and we will lay all those processes on one line so that even if one process is not as accurate as the other, we can still have got a perfectly working system in the end. So this is basically what I just wanted to tell you. And of course, we are at EPIC, and now we always have to discuss what we can do for you and what you can do for us. And that's what is displayed on this slide. So what we can do for you is everything that has to do with glass molding, process development, for example, feasibility and cost studies, and optimization and digitalization. And on the other hand, we are a research institute. We do not have a running production. So it would be very interesting for us to have got some real-life test beds in companies, for example. And we are always looking for industrial partners for publicly funded projects. And of course, we like to know what are the next level challenges that you are facing and what you would like to have developed, for example. And that means if we talk, I just presented you something about digitalization, and actually I would like to know from you now, is that already a topic that you want to address in the next few months or years, or whatever your short-term horizon will be? So thank you very much. And now I'm open to questions, of course.
Thank you so much, Tim, for this very nice talk. And the technology you showed us right now, or the digitalization technology you showed us right now, did you specify a material there, or what are the materials you think it's applicable for, or just glass?
Yeah, so we are right now focusing on glass, but there are no limitations to what type of glass. Maybe of course fused silica is still a bit limited because it has got a very high forming temperature. But going from chalcogenide glasses to soda lime to low TG and whatever, this is all possible. And of course, we have got a department at Fraunhofer IPT that is also dealing with injection molding. And this is also possible in the future to expand this model to this similar process.
Yeah, thank you so much. So let me introduce you to micro resist in the room. Hi.
Hello, everyone. I hope you can hear me.
So would you like to answer the question of Tim? Or tell us also about micro resist. Yes, we can hear you.
Well, what I can say is that micro resist technology is a material supplier for the polymers. You know, I don't know if polymer and glass, if we should compare the number of the money you spend for the materials. But what I would like to point out is that micro resist is offering rather intelligent raw materials, right? So we are not a supplier for the raw materials for injection molding, rather than for the folks of Suze, who already spoke, or Orlando Ferrini from Fabulous Projects. And I think Neil also is in the room. So we are supplying intelligent photoresists, which are used in micro and nano patterning techniques. So this is a little bit different from what Tim just mentioned. But whenever a micro and nano fabrication process comes into play within the process chain, then micro resist technology, based on its portfolio, would be a right partner to talk to. But we're also here to learn about, you know, the application requirements down the road, what is needed by the partners of Volvo, and of course also our research partners such as Fraunhofer institutes. That would be my quick answer to that, Sana, without having an immediate, let's say, interaction to Tim.
Okay, there is here the place to make more interaction with them, and there is always the chat that you can use, of course. Thank you for your comments. We have also, when we speak about material, we have Stephan from DELO. Stephan, I have to hear your comment on this.
Yeah, hi, Sana, thank you. Similar to micro resist technology, DELO also offers polymers, not really related to glass. And also not really comparable, as we all know, this is kind of a different universe, but still we have some advantages compared to glass. And let me share my screen real quick. So what DELO does is we not only offer also optical materials for application, which are tailor-made in terms of the optical properties and can be used in a wafer level process. As a rather large company, we also offer adhesives, which is our main business. For bonding of such components as, for example, microlens arrays, for active alignment in headlamps, which are reflow stable. We also offer scattering materials. We one step back for LED packaging. In different areas, we offer materials for lens bonding, frame bonding, for die attach, electrically conductive adhesives, and you all get this stuff out of one hand. So this is our expertise. Everything out of one hand. It depends always on the application what you need, and DELO is there to make a customer specific solution just for you.
Thank you, Stephan. I think it's nice to. Jose, would you like to go back to Volvo?
Yes, but before that, for me, the materials are a key challenge. I want to go back to Tim first. Tim, I think here is when we have to look at your Santa Claus Christmas letter. We need to find out what is your wish list in terms of material. Tell us a couple of items there, and we'll find them for you. This is when we excel. But tell us what you really need, what you really want.
Yeah. Oh yeah, I'm still unmuted. Okay. Yeah. So my Christmas wish list. It's very early for that, so I didn't think about that in terms of Christmas. Yeah, of course, we are interested in companies that are using glass optics for, I don't know, also automotive lightings. We had a couple of projects with that, but also for camera systems or for laser systems or whatever you can think of. But we're also interested in some polymer technologies, like exactly, for example, these kind of structuring. And because there are always some possibilities maybe to transfer that one day to those higher melting materials, like, for example, glass. And
today, Tim, when we were actually defining the supply chain, you can see here that we actually define separately the materials for glass and for polymer. And the reason for that is we have two different sets of challenges, and I think it's the best time to address them now because I had the best companies in the world on that. First, I'm going to go to Finland. I'm going to go to Finland because I have here Oplatek. When it comes to glass molding, in my opinion, they are the best. Kimmo, what brought you to this meeting? And most important, we had the presentation already from Volvo, very interested on glass, from IPT, very interested in partnership on glass. What do you bring to the table?
Yes, we have with Oplatek a special kind of glass molding method. This is called non-isothermal molding. Fraunhofer knows this very well because they have studying this method for a long time. This is not exactly precision molding. So if you Google glass molding, you probably end up finding a lot of precision molding methods. This is not that. So I can immediately say that our tolerances will not be comparable to precision molding, but this is a really cost-efficient way of doing molded glass elements. So what is non-isothermal means that the mold and the glass are at different temperatures. So you don't need to heat up the mold as for a high temperature as in precision molding. So it's the cost efficiency is the key, and I'm really looking forward to deepen our discussion with Fraunhofer in view of doing more fully automated glass molding line. Most of our process steps are already automated, but it's not like whole process is automated. And here it would be interesting to deepen our collaboration. And I know that in Europe and in EPIC portfolio, there are other ways that we can combine. For example, I raise here Leopil and the various casting methods available, so that because we don't have the really high-end kind of dimensional tolerances, but we can advance our kind of tolerances with the help of other techniques here in the table.
Thank you very much, Kimmo. And I also want to address right now, with the people who spoke already and the ones who are about to speak, the topic of turning systems. The reason why I want to address this topic is because we do want to match what PanDao told us in the beginning, all the different manufacturing processes. We have two of the key companies in Europe on that topic. We have Innolite, Christian, all the way from Aachen. I know Tim knows you very, very well, so it's not for Tim, you are neighbors, it's for the others. Can you tell us a bit how you saw in the last years the development of turning systems and how you see a growth on the different materials or different applications that you are actually taking to the market? Christian is muted, doing an honor to the Mac I got order. On one hand, you are muted, on the other, 700 members. Thank you, Christian. But you need to unmute yourself. Yes. Let me see. We can unmute you. Bottom left to the Zoom window. There's a mute button. Just click on it.
Oh,
there you go.
Here. Now you can hear me. I'm sorry. I was talking to myself. So this is about mold making. We've been talking about the replication, but of course there's the question on how to generate the mold, and the diamond turning is a key process for the standard molded optics mold manufacturing. And as Tim has mentioned, the molds for polymer optics can be made out of steel, they can be made out of nickel phosphor, they can also be made out of brass if there's low volume. And all these materials can be diamond turned quite easily. Brass and nickel phosphor directly, steel, there's good technology with ultrasonics to cut. For the glass molding, there's the tungsten carbide that is usually being used as a mold insert. And there's a lot of work in this field to actually enable also diamond turning of tungsten carbide laser assisted in order to substitute the grinding technology. The grinding technology is, I would say, it's a limitation in geometrical freedom. The grinding is a very complex process, and Fraunhofer IPT is developing grinding in a great way, and they're experts in the field. Nevertheless, you have a bigger radius just by the approach itself compared to a diamond tool. And for new cell phone applications, for example, cell phone lenses made out of glass, there is the need for small mold inserts made out of tungsten carbide. And the turning technology will have to answer these questions for the future. That's my understanding.
Thank you very much. Do you have a challenge for this room? We have from the end users all the way to material suppliers. Everyone is here. A challenge, an item, a room for cooperation, so I can make an introduction and do my job and sleep well tonight.
Well, the challenge, we've been talking about the materials for the optics, but there's also the challenge for the materials for the molds. And these tungsten carbides or tungsten carbide alloys behave very differently if exposed to laser radiation and being treated by diamond turning. So I think there is a big challenge to have a new material class that allows for high productivity, as Tim has said, in machining, high precision, and high mechanical and thermal stability during the replication process. So that's my contribution to the wish list for Christmas. Let's have new tungsten carbide materials that can be turned into great molds.
Oh, that's a good one, and we're going to come to you on that. But now, before we go to Leica, and I know you are all waiting to hear from Leica, I need to go back to Paul-Henri from Volvo, because we have a question from you all the way from the YouTube channel. All the way from Tokyo, Sumitomo Electric, Yoshiki-san, he's wondering, does a smart high beam need special optics and have something to be solved? He's talking about the challenges for your high beam.
Yeah, yes, I think I have answered. I think Sumitomo is speaking about the HD technology with what we call micro LED with 20,000 pixels, something like this. So I think the main issue for optical design is to have a good contrast between the different pixels, because we should define a cutoff line, so where we have light and where we have no light, and the contrast is very important. And when we have so many small pixels, so this contrast can be difficult. So we need a very good accuracy in the optical design.
Thank you very much, Paul-Henri. And I think you're going to have a discussion with my friend Yoshiaki-san from Sumitomo offline. But it's a company in Denmark. A company is called Nil Technologies. I think we have Niklas with us in the room. Niklas, what you have managed to do a business of is to in the beginning, being a company that make masters, but you managed to do wafer level nano optics based on replications. Here we have the concerns of George saying, okay, we have to go to address other markets that are very targeted to go from individual lenses to wafer level optics. What is your take on that? What kind of room for cooperation could there be here?
Hello, everyone. So it's a great question. When I heard you speak here, Jörg, I directly thought about one of our product categories, the meta optics, because this is when you have a really advanced optic element, and you want to produce that on a wafer level scale. That's really when you can go to the meta optics. So it basically solves this problem, and the reason is that with meta optics, the complexity is the same, no matter if it's a simple lens or if it's a difficult lens. It's the same level of complexity. So once you master the production route of meta optics. You can make simple lenses and you can make advanced lenses, and the level of difficulty is the same. I also want to mention we do diffractive optics, regular diffractive optics that we do on wafer level scale in UV curable materials from, for example, micro-resist or DELO. There we do diffusers, fan-outs, collimators, and regular lenses, and we can combine these different functionalities on the same chip. We also work with future displays where we do slanted and blazed gratings. Since this is about molding optics, I also want to mention that we have capability to apply micro nanostructures on curved surfaces. So here's a steel insert where we have applied a micro nanostructure. And you can also see here some examples of how these structures turns out after being injection molded. So first example is a 4-level diffractive optic with a minimum feature size around 0.5 micron. So it's really small features. And despite that, they actually come out okay in the molded copy. You do lose some integrity in the structures, but it's not that far from being a solution. Then when it comes to MLAs, we have an example here with an MLA which has a nano roughness. And you can see an injection molded copy here with where the MLA comes out, but the nano roughness is lost. Then we also tried this with UV molding, and there the accuracy is much higher. So this is an MLA on a curved surface that was molded with UV.
Thank you
Absolutely,
very much,
Niklas. Wonderful. Yeah?
George. This one, Nilt, is one of the ones to watch. George, we're going to have a drink in 5 years and you will see that I was right. This is one of the ones to watch in the Europe right now. But I want to address another topic. You talk very quickly about the glass touching the mobile phone market. And on that, we have Henrik Madsen from SPIO. Henrik, thank you very much for joining the meeting today. What's on your mind?
I just want to mention that there has been some news on the wafer level optics or wafer level production of mobile phone lenses. I know that the ASC in Kaleido just announced that they are now producing wafer level optics for mobile phones. But that's from my previous employment on Kaleido. We are in Spire System. We are doing wafer level micro optics, not in glass but on polymers. I could show you a small.
Go ahead. We all want to know because we want to work with you. George is as excited as I am.
Okay.
Yes, absolutely. Let me say before you start, just in the minute, let me say a quick word to Niklas. Yeah, Niklas. I mean, it would be wonderful to have like a DOE or a meta surface for color correction. Yeah, and so if you have state-of-the-art technology, just please talk with us. Yeah. And let's.
I will reach out to you through Jose.
So Spire, let's talk about that.
Yeah. Okay. Spire is a young company. We are doing. Our aim is to do wafer level optics, but not only one layers, but multiple layers. So we want to stack multiple wafers into a stack. So our idea is to make very compact and very complex optics on wafer level in polymer. So that's our aim, and now we are producing single layers, and we do true integrated optics. We can do both lenses, mirrors, polarizations, gratings in one layer. So we are aiming doing very complex optics in wafer level, and also do stacking of wafer. So we have multiple layer optic processing on wafer level. That's our aim, and that's what we're working on. So that's the short message from our side.
But tell me what kind of challenge, what kind of cooperation you could see with the company so far in the room. This is what I like. This is a collaboration meeting, Henrik.
Okay, we have a good source of mastering. We get masterings from Milpon Optics also in Denmark. The challenge would be to have it glue it together. So we are searching for manufacturing of gluing components. Also, we know that the market has no stacking capabilities or equipment for stacking. So anybody has experience in do multiple layers of wafers, stacking, liming, that we are searching for capabilities on that. But also wafer level metrology.
Wafer level metrology, wafer level stacking. We're going to make a lot of introductions there.
Exactly.
George, back to you. We talk very quickly in your slide, in the beautiful slide that Sana and me like so much, about the activities on lens assembly. And here, when we talk about wafer level optics, people are very, very, very happy with passive alignment. When we talk about micro lenses, individual alignment, we are very happy with active alignment. Could you share with us one challenge, one room for cooperation, one thing that we could do maybe here together?
Well, I mean, I think the big challenge in the assembly will come when it goes to hybrid, when we combine plastics and glass lenses together. And that could well come because the industry requires more compact lenses. And when it goes to more compact, then we usually talk about higher aspheric ratios. And when we talk about higher aspheric ratios, maybe at some lenses you will not manufacture in glass anymore. Maybe you then at a point will manufacture in plastics, assuming that the plastics is durable and reliable and it doesn't change in color and all these things.
And there is one more company, George, that I want you to meet. There is a company called Glassomer. And Glassomer is here for the first time at an EPIC meeting. Frederick, welcome to the family, Frederick. Glassomer was very interested in looking for partners and identify Leica as a potential partner for them. Tell us here what you want to do. You have end users from Volvo all the way to glass manufacturers like Schott. Many companies who can help you. Tell us what you do, and most important, how we can help you doing it even better.
Thanks very much, and thanks very much for having me here. Really happy. We discussed so much already about glasses, which have these amazing material properties for optics, transparency, stability. And we have plastics on the other side, which are super easy to mold, where we can get the high resolutions, where we have scalable processes like injection molding. And that's basically where we come in. We are a startup from Germany, and we are glass component manufacturers who found a way to make glass structuring as simple and as efficient as polymer shaping. Therefore, we have developed new materials which we term glasomers, which come, for example, as thermoplastic solids, as a granulate. We also have liquids, photocurable liquids, which are basically a mixture of a really high amount, of, up to 85% weight, of silica within a binder matrix. And you can shape these materials using classical polymer shaping technologies. So for example, injection molding on an Auerburg machine, or 2-photon polymerization on a nanoscribe system or up nanosystem. What you get out of the shaping process is a polymer component, which is called the so-called green part. And then these components are put into an oven and are converted into glass. What you get in the end is high purity, highly transparent fused silica glass with the same material properties of commercial fused silica glass. Here, down here, I just want to show you some of the technologies which we recently have shown. On the right side, you, for example, see a 200 on 200 3D micro-optical lens, which we have printed using 2-photon polymerization and then turned into fused silica glass. And this is our latest technology, high throughput injection molding. So in the back, you can basically see the green parts, which we're injection molding with cycle times of a few seconds. So we could make thousands of these within an hour. And then they are basically converted all at once in a batch process to glass within 20 hours. What we're currently looking for are partners in the field of optics, photonics, who have innovative new products, innovative new components which they want to fabricate in glasses. And really specifically what I want to ask also today is we're currently in the application for an EU project where we want to roll out new innovative optical components for sensor applications. So if you want to join, if you're a European company and you want to join in that, I would be happy if you send me an email or contact me via my email address. And that's it. Thanks a lot.
Looking for
I'm happy to take questions.
Sensor manufacturer, SME, European SME sensor manufacturer who would like to take this to the next level. That's correct, right?
Yeah,
or can it be anything else?
Optical components, micro-optical components, everything around that. So the main topic is sensors, but can be optical components too.
Fantastic, because Wilfred from SUS Micro Optics has a question for you. Wilfred, what's on your mind?
Thank you for calling up, Jose. I wonder, what is the shrinkage typically of these materials? So when you have a mold, and so first of all, it has to demold easily. So that's more the chemical problem, or chemical situation better. And then the other thing is, when you have shrinkage, you have to do a lot of compensation, form compensation beforehand. So we have the materials we use have in our imprint process typically low shrinkage, but form compensation can already be challenging. So if you have more than 5 or 10%, it might be very challenging to pre-compensate those shapes in a single iteration. Just wonder what your experience is.
Yeah, so I think it's two questions, right? So the mold is basically we can use stainless steel molds for the process for injection molding. We also worked a lot, what you can see up here, with soft molds, PDMS molds for UV casting processes. During the shrinkage, we have a shrinkage during the sintering process, but the shrinkage is extremely isotropic because we have spherical particles within the matrix. So it's a little bit different from the classical ceramic injection molding. So shrinkage is isotropic. Our standard formulation have around 60 volume percent, which then correlates to 15.6% linear shrinkage. But you can go up to 85 volume percent. Then you only have around 9% linear shrinkage. But as we found, so we did already diffractive optics, refractive optics with that, diffractive optics with a layer height of 250 nanometers, for example, using thermal nano imprint. Happy to discuss that further, where you need an extremely high precise shrinkage compensation, and that's quite easy because it's an isotropic shrinkage.
Okay, we should keep talking.
Another question in the room for you, coming from turning system maker and mold maker Willenheber GmbH. Andreas Schaffer, what's on your mind?
I was wondering, during the sintering process, do you get any internal stress or things like that which might produce micro cracks? Because always when we have these processes where we go from, for example, from silica to glass with sintering or physical process, we always get topics of micro cracks.
No, so we don't have any micro crack processes for the, I mean, our standard material is fused silica class. That's also some because we have that low thermal expansion. It's 0.5 to 10 to minus 6. You can basically heat it up as fast as you want and cool it down the fast your oven can go. We even did microwave sintering of that, and you never will face any issues of basically internal stresses. If you make multi-component glasses, you have the same as for all glasses. You basically have to temper at some point.
No, I was wondering during the sintering process, because during the sintering process, of course, you have normally some areas which are already of glass and some are still of the old polymer. And there I thought there could result internal stress.
Yeah, so basically the main trick behind our technology is we found a way to get rid of this binder, which is before the sintering process. You have a debinding step where you remove the binder, and we can do that either by a 2-point step where you remove one component first, you create a porosity, but only a porosity in the binder through which you can afterwards burn off the organic. This is mandatory because, as you said, if you would use a pure polymeric binder and you heat it up, you turn a solid into a gas, and that's normally called an explosion.
Thank you very much. This is your first appearance. I'm going to go back to George. George, it was your first ever EPIC meeting. There's many people who ask me to be in contact with you. There is a question in YouTube. Somebody saying, can you consider laser machining for prototyping of freeform optics? Don't answer that question yet. I want you to see the next presentation by Michael Reyes before you answer it. We go all the way to beautiful, beautiful, beautiful Barcelona. Raul is here with us, the CEO of Michael Reyes, to tell us, most important, how we can help you do what you do, even better than you already do it.
Hello, Jose. Thank you so much for this presentation. It's always a pleasure to be here. Can you see my screen?
Very well. Go to a slideshow mode so we can see the quality that this deserves. Perfect.
Okay, thank you so much. Okay, I will speak today about in this online technology meeting on molded optics about the femtosecond laser engraving. Is a job that we are doing in this kind of molds. Okay, As Jose said, I am Raúl García, the General Manager of Microrelleus, and I will explain in this presentation just 1 minute about who we are and what we do, what a femtosecond laser technology is as well, just 1 minute. And then we are going to focus directly on the mold microstructuring for lighting and mold texturing. So that's our company. We are based in Barcelona. We are a workshop. We are a service provider for industry. So what we do is industrial engraving, laser texturing, and laser microstructuring. We are in the market since 1983. And this presentation is based in the femtosecond laser. So what a second laser is? Femtosecond laser is an ultra-short pulse duration laser. There is almost no thermal effect over the material. And thanks to this cold ablation, we can achieve micro-engraving, microstructuring, texturing absolutely burr-free. So absolutely under control. We have here a sketch, a comparison against the nanosecond laser where there are some affection. So in terms of microstructurings, we can create microstructures and free-form micro-optics in tempered steel inserts, both in flat surface or 3D shape. Benefits: to obtain smaller details in a conventional mold. So new design and functional possibilities. Regarding texturing, we can texture inserts to achieve different properties like light diffusion, for example. So because of this cold ablation of the laser that we spoke before, we can engrave microstructures absolutely burr-free with very good tolerances, high quality surface finishing, and with very sharp edges. If we compare with the minimum size we can achieve using conventional technologies like milling machine, we can achieve radius less than 10 times smaller than using those technologies. And because we are working from a CAD file, there are limitless design possibilities. We can engrave free-form micro-optics and microstructures on mold inserts. Here we can see an example of those microspheres in high relief. That's the finishing we can leave. And even smaller. Here we can see some pyramids with a pitch 200 micron. And not just on flat, but also on big 3D shaped inserts. Here we can see a lot of micro ovals from bigger to smaller sizes. This is a project we did for our customer Daisalux, a very nice and innovative company in the Basque Country. And in this case, they designed this free-form micro-optics here for their specific purpose. So we engraved the mold insert using the femtosecond laser. You can see here an image of the insert and the final product injected, and the comparison of simulated value versus the measured value in photometry after the plastic injected part, as an example of possibilities. In the Seat Leon 2020, for the signal mirror indicator, customer wanted to achieve some specific texturing in the blinker. So we engraved the PMMA prototype. So because of this cold ablation of the laser, we can engrave over any material. So we work a lot for prototyping as well, directly on PMMA or PC. Then we textured the final inserts, and we here can see the product which is in the market in the Seat Leon. Regarding texturing, functional texturing, and regarding light diffusion, 3 years ago, we did a project trying to avoid the hotspot of the LED. So texturing the mold and injecting transparent PMMA. So we had some problems in terms of repeatability and so on, because we used nanosecond laser. But 2 years later, we began to study the possibility to create some roughness in the mold using the femtosecond laser to achieve this homogeneity. For this purpose, to achieve this light homogeneity. Okay, so the important points we took into consideration for the design of textures was diffusion, quality, and luminance, but also repeatability and stability of the texture. That's why we used the femtosecond laser. So burr is having no influence on the diffusion, so it is a very controlled process and textures over any material and conditions. Here we can see diffusion in one direction, two direction, or the homogeneous one. And here we can see a comparison between the nanosecond laser and the femtosecond laser. So even we can see two microstructures that seems to be the same. When we analyze with confocal microscope, we see big deformation on the shape and the profile when using nanosecond, and very good definition when using femtosecond. The same here, where we can see the difference in very sharp edges and very good definition of the sphere in the femto. To finalize with examples, this is a test for our customer Weight Plus, and they wanted to obtain for a light guide application using microstructuring. So for this light homogeneity all across, all along the area. So here we can see 3 textures engraved high relief and 3 engraved low relief for this purpose with very good homogeneity, as we can see in the images. So to finalize, we have confocal microscope and small photometry laboratory to obtain basic measurements, because we are just we are an engraving workshop, but to be able to deliver the quality that the customer requires and to gain more knowledge all about these lighting possibilities. So that's everything. Thank you so much for your attention, and please feel free to ask.
Raul, I'm extremely impressed on how many success stories you have of building high-end optics to customers all the way for the automotive. So I want to go back to Leica as promised. I want to go back to George and ask you the question that was for you in the chat, but after this presentation. Have you considered ultra-fast laser process for the manufacturing of freeform optics, George? I have you muted, which is unfortunate. Bottom left corner of the, yes, there you go.
So no, that's good. Yeah. No, we haven't actually. Yeah, it's really good to consider this. Yeah? I mean, we need to think. We need to see whether, in terms of accuracy, in terms of hazing, or so, this is appropriate for the optical quality that we need. But let's give it a try. Why not?
Absolutely.
That's the perfect answer, right, Raul? Now let me go back to you, Raul. I want to understand a bit. We all heard already in the beginning from Volvo about their challenges. We heard also from Fraunhofer IPT. What kind of room for cooperation? Let me see if Paul-Henri Matha is with us still. Paul-Henri is here with us as well. Let me see what kind of room for cooperation could we have with these companies. Tell us about the EPIC question.
Well, finally, what we can offer is this new technique of engraving molds. So there are new design and functional possibilities. And what I would ask to the companies, what you can do for us is finally communicate with us. Just tell us the problems, your new proposals, because maybe could be a good solution for that, and maybe we can help you.
You know, today we have in the room a company that offers like a one-stop shop for all plastic molding solutions. That company is called All-in Optics. And we have Lars Nakote with us. Lars, what's on your mind? What kind of room for cooperation can we do in this matching between Macro-Regeus and All-in Optics?
Yeah, thank you. Very interesting. Also, these main topics that were introduced. So, my question was, what kind of limitation are there to the overall size, to the parts that you can engrave, and maybe again some more details on, let's say, the smallest possible feature size that you guys are able to do.
Okay. So regarding the smallest details that we can achieve, we are comfortable in the range of dozens of microns. So this is not comparable with some other technologies that were before, or like some companies that I can see here in the screen, because we are comfortable working in the range of 100, 200, 300, 400 microns, okay, of pitch of structure. For example, we cannot speak about nanometers, and we cannot speak about a sphere of 10 micron diameter, for example. And regarding the biggest size of part that we can engrave, its machine movement is 600 millimeter per 400 millimeter, but we can stack the part in different ways. So we have engraved parts bigger than 1 meter, 1000 millimeter. So it depends a little bit on each case.
Thank you.
Thanks.
Thank you so much, Lars. Thank you, Raul. When it comes to the material of the mold itself, what type of molds you can produce as well? Because earlier we heard that the material of the mold itself is a challenge, right?
Well, in our case, most of the cases, 99%, I would say, we engrave directly on steel, stainless or not stainless, tempered, not, with coating, without it. So there are a lot of variants, but most of them are from steel, and we have no problem to engrave them.
Thank you so much, Raul. Let me see if we don't have another question in the room. Then there is another very large application of molded optics is in the glasses and the wearables. And we are very happy to have for the first time as a speaker, Shaq from Cora Technologies. Shaq, you can unmute. And we are looking forward to hear about the success story of Cora.
Hi.
Yeah, hi.
Good. Yeah, I'm really happy to be here. I've learned so much already just today. This forum has really become, you know, a go-to for me to learn new things and get current with the industry.
Why don't you just start sharing your presentation? We are very happy to see. We see that you joined other meetings, which is really good. And today we want to hear your success story and see how we can find collaborations with other members in the room.
Okay, I'm trying to get, sorry.
I think we have, meanwhile, Jose, why don't you share with us loudly your comment? That seems very interesting.
No, I just get excited. This is one of the ones to watch. The CEO got the award of 30 under 30. It's a company that is raising a lot of attention worldwide. 150 degrees field of view, 4K resolution. I can't wait anymore. The floor is yours.
Thank you. So this is kind of an exclusive, Jose. This is the first time we've showed this concept in outside a very narrow community. So I'd be happy to have your feedback on how it looks. Okay.
Wow. Excellent.
Okay. Let me. There we go. This is the target of our device. We call it gallium. 150 degree field of view. Very lightweight, 80 grams. It's very high transparency so that you can use it in daylight and in telepresence. 8K resolution, very crisp and clear. We're going for a very wide range depth of field and very high brightness. I'll show you a little demo at the end here. We're really focused on using a geometric waveguide and eyepiece. You'll see a little picture of the optics and some of the folks we've talked to today have given us some input, and we are looking forward to collaborating with them on helping to make this more effective and more cost, focus on cost for these consumer electronics. We have head tracking, eye tracking, all integrated. This will also support tethered and untethered operation, okay? Our headset, you can see there, this geometric waveguide, very efficient and gives us a very large eye box. You've seen some concepts like this in other places, but ours, as we go forward here, you'll see that this is quite unique. We've developed a custom micro LED display engine with a custom backplane, and we're working with micro LED manufacturers to generate the light engine. Enabled, our micro LED driver chip can demonstrate 8K resolution, and we're really trying to focus on established manufacturing technologies and move towards a very cost-effective device. You can see we've got a few prototypes here. Kelly's there on the right. My pre-COVID haircut there on the left. And, we've had a number of different things where we've demonstrated these capabilities and are moving towards volume production. Our LED display is going to, it gives us really true blacks, very high brightness. I think that the community here understands the AR applications and how important those things are. I think that you've seen a number of different offerings in the industry, and we think that this set of features will be very competitive. We have also are able to accommodate the current state of the art in the LED or micro LED industry, where there are still a lot of optimization going on for yield for other applications, where we think that we'll be able to use these designs earlier than others. We're about 24 people right now. We're expecting to grow. We're in the middle of a funding round, and as we come out of that, we'll be doubling that head count very quickly. Our gallium headset that I showed you earlier is due to launch the end of this year. The focus is really a global telepresence platform. So hopefully we can do these meetings using gallium someday, soon. We'll be ramping up our production in 2022, next year. And we've got a number of companies that are quite interested in getting access to this. Let's see, this is a demonstration that we shot through our lenses. You can see that we've accomplished some good stuff here. This is really fun to play with. Okay. So thank you for the chance to talk. Like I said, I really have learned a lot just today in my role in sourcing, and you've already done a lot for me in this forum, Jose. So I want to really thank you for it. Okay.
Thank you so much, Jack. Thank you for this fantastic presentation. But let me tell you a thing about EPIC. Once you present what you can do, you have to also tell us what can the others do for you, or what kind of collaborations you're looking for, particularly that you're responsible for the supply chain. So you should know.
Yeah, like I said, I think that we've had a lot from this forum already. I've made a number of connections with the sponsors and some of the people already in this room. We're really looking at multiple generations of technology. This particular version is our launch, and we're looking at the next 2 or 3 versions of this product and this platform. And so we're looking at how we can make this more efficient, more cost-effective, and move to better and more advanced technologies. So, all of these display engines have multiple elements, and there are many opportunities for us to collaborate with all of the technologies represented here. So thanks again. I'm open for any kind of suggestions, or I'd be glad to hear from anybody who feels like there's opportunity to reduce our cost and improve the performance of our product. Thank you.
Thank you. Let's see about when it comes to glare. How can you reduce that? We have Ralph here from Inoptic. Ralph, what do you have in mind?
Yeah, thanks for having me here today.
and congratulations to Kura. I think the datasheet is very impressive with the 8K and also with the 6th dimension. But I'm not sure if you are aware of Optic. We have been busy for a couple of years in the field of anti-glare systems. So whenever you would like to try out your glasses outdoors, even against a deep standing sun, we are able to distinguish between wanted light and unwanted light. So in other words, you could suppress the sunlight by 98% while seeing your content, which is the essential content you need to see, you want to see. If this is somehow interesting for you, let's engage and see what we can do for you. Maybe.
Sounds very good, Ralph. Thank you.
Thank you. Thank you so much. Does anybody else have a question?
I have a question from the YouTube universe, all the way coming from Tokyo. Again, Sumitomo Electric, they have a question for you. Does 8K images need data transmission by cable?
Well, the short answer is yes. There's a number of different things that we're doing to, to use video compression to make the driver efficient. I'd be glad to talk to you with you offline. That's a pretty deep technical discussion to get into here.
All right, now for me, this is, I would like to tell you, Shiaki-san, this is the core know-how of Kura on the video compression that they are doing, and on that they had the golden egg. And I'm quite amazed that you came here sharing, looking for partnerships here. I would like to ask you something else. We are talking about molded optics today, and one of the problems that we do normally have with this technology is the need for high-end filter solutions. Is there any item in your Santa Claus Christmas list, any wavelength band that you would like to filter out, and you would like to do this in a thin film, in a fantastic professional way?
I'd have to, push that question to our technical team, Jose. That's a good question. We're looking at a number of different technologies that improve the performance of this whole optical stack. But you can see that we've made a pretty good progress in simplifying the stack and getting it down to the fewest number of interfaces. So each of those interfaces become more important. And so, yeah, there are opportunities for better coatings and better optics.
We have another question for you coming from ABC Engineering. Sandeep, what's on your mind?
It is nice to participate in this presentation, the webinar. Quickly, I just want to know, we are into the field of LED lights. We mostly use light housings with reflectors to focus or spread the light onto the task or the object. Now, are there any specific advantages of using lens as optics vis-a-vis the reflectors?
I don't know. I couldn't answer that.
I'm not sure I understood the question either myself, but maybe when it comes to this, maybe we'll address it offline. I would like to go to Leopold. Ralph Lloyds, he's the CEO of Leopold, and one of the companies who have helped many members in the optical design challenges. Ralph, when you saw the presentation from Kura Technologies, of course, I know some of your customers have developed wave guiding technology that is very, very interesting. But how do you think we could help a very, very promising company focusing on the 8K resolution, but we want to make AR goggles? How can we help them, Ralph? Unmute, most important, because I want everyone to hear your voice. You're one of the biggest optical experts I know, so yes.
Thanks. Yeah, but well, we haven't really found the holy grail on how to get AR really moving. But then I guess the optical quality is a problem, and the field of view is always an issue. So when you need to have optics that are high quality, and that's, I think, where we are all standing for. That's what we can do. You have to have them shaped, right? Which is something most people cannot yet do. But I guess with processes like casting, that would be easily possible.
The reason
But then
why I brought you to the table,
you're already there, right? I mean,
Ralph,
we can do DOEs on it if you need that.
no, we don't need that. But Ralph, wait, because Ralph and Chuck, I want the two of you to be here because now I'm going to open a triangle. I'm going to Ross Stanley from OptiRoss because this is the question. Ross, ask the question because I want to hear from the optic expert Ralph and from the success story, Cura Technologies, if there is an answer for that.
Yeah, sure. The 150 degrees field of view is a real challenge, particularly using waveguides, because you have some fundamental limitations of how you're going to get that. Can you reveal how you're going to get there?
Well, you know, all of this technology is still pretty well protected, and so we're not sharing IP in this particular meeting.
Okay.
I fully understand that. And please don't. I don't want to have any issue. But okay. But back to Chuck. We talk about this technology being the instrument of the future. For me, I am amazed at what you want to do. But I would like to tell us, if we had this meeting maybe in 3 years, what do you think? What kind of things do you think you would have accomplished by then? The company is alive for 6 years, and I cannot really tell you enough of how impressed I am of the last 6 years. But what is the next step? And tell us, dream away with us. What is going to happen?
I think you'll be seeing. I think that if we were to present here in 3 years, you're going to see, 2 or 3 generations past this that are on the drawing board and being developed in the background. So we're taking this concept and continuing to develop it out into the future. And there's a number of different degrees of freedom to exercise here. Where we see LED technology advancing, where we see this the micro-optics advancing. And we think the fundamental concept is a good one and has long legs in terms of continued optimization. But I think you'll see us continue to build on this capability, make it lighter and stronger and more cost effective.
I cannot say it enough. We have the best micro-optics technology worldwide right now in the EPIC community. We work very hard for that. We build a fantastic community on this. Ralph, a final comment for Cura, for the rest of the speakers.
Yes, also to Charles. We have seen many layer structures nowadays, because if you want to add correction glasses to your AR system, some might need correction glasses. What we see is that we need coatings as well. Of course, the usual suspects like Hoya, Zeiss, they know how to do anti-fog, anti-scratch. But I'm wondering if there's anybody here in the room who could offer something new on the future horizon in the field of anti-fog and anti-coating. This is a very underestimated field. As you see, even nowadays, when you wear your mask, your glasses are immediately full of fog and you cannot see anything. Is there anybody here who could offer new coatings for the future?
You know what? For me, I am not aware of a solution for that, but what I'm aware is we have one of the best coating suppliers worldwide in the room. We have Hoya, Oliver Post. So Oliver, is you're here with us. Congratulations, by the way, on your new job. It's your first ever EPIC meeting on Hoya. You are already an EPIC VIP for your previous position. Oliver, you heard a lot of stories in the last 2 hours, and you also had the challenge from anti-fouling coating from Inoptech. What do you bring to the table, and what kind of cooperations can we do with you? You are muted. Yes. As Oliver from PanDao is telling you are muted, which is, yes, now we can hear you. No, we cannot.
No, now you can hear me.
Yes, I can, yeah. But yeah.
Thanks. I heard a lot of very interesting things. Usually say that, but I really mean that. And my impression is that the glass community and the plastics with all the variety inside community is merging, not only in terms of nanometers with swimming silicon in plastics, but also in terms of applications and technologies. And for that, I think it's worthwhile, or it's very important to zoom out of all the technology details and start to discuss about the connecting field, the overlap, so to say. What is the strength of this and that, and how can I, as optic designer, decide in which swimming pool I should jump, plastics or glass? And tools like we have are one step in that direction. They don't go into too much detail, but the general rule in the beginning, should I ask for a budgeted project in this direction or that direction? This is the goal, I think.
Fantastic, Oliver. And from Oliver, PanDao to Oliver, Joya. We talk about one of the leading coating suppliers worldwide, Joya. Oliver, tell us, do you have a solution for Ralph on the anti-fouling coating? And is there, what do you bring to the table to this community?
Actually not. But I participate in this meeting because we make glass molded lenses, so I'm here to learn about that. We make coatings, but these are interference coatings for filters, but no anti-fouling coatings. I'm sorry about that.
But Ralph, I'm going to take your challenge. It is 5 minutes to 5. I think it is time to close this meeting. I would like to say that I always close the meeting with a summary of learning points from the meeting. But today, Leica made it very, very easy for me, because the fact that they're coming here looking for expertise and help on all these 4 different sectors, from the optical design to lens manufacturing, lens assembly, and lens characterization, from wafer level optics to freeform optics, from combining different technologies and different materials, that was gold. So this is huge room for cooperation. That's why I'm going to dedicate the summary slide to Leica today. It was great to have you in the room, and also all the others. You were all fantastic. You know what I want to say? I will say the same thing. The meeting looks like it's finished now. Because it is 5 o'clock, it looks like it's finished now, but it's not. The most important part of the meeting starts right now. It's when you follow up. So if you want to get in touch with any of the participants today, drop me an email, jose.pozo@epic-asset.com, and I will be so happy for making this introduction. And also remember that today is only mid-season of the season 4. All the online technology meetings that we're organizing, already 100 since the pandemic started, 100. I want them to I want you to look at them and register as soon as possible. Take on Molded Optics. Next week is urology. In 2 weeks, laser micromachining. In 4 weeks, we have human-centric lighting and application. Pixels we have beginning of June, 14th of June, surgery. And in 28th of June, we have different photonic solutions. We finish with laser cutting. Here, on behalf of a fantastic team of experts that work at Epic and dedicate our life to you, to the Epic members, stay healthy. Wash your hands, wear a mask, and get vaccinated, even with AstraZeneca, because I can't wait to start traveling again. See you soon. Bye-bye.